Okay, now the question says a ball of mass 2.5 kg is attached to one end of a string whose other end is attached to the ceiling of a room. The ball rotates in a horizontal circular path such that the string makes an angle of 45 degrees with the vertical. If the distance of the center of the circle to the ceiling is 2.5, then find these parts we have to do. Now according to the given question, the ball of mass 2.5 kg, it is attached to the string. So here we have shown, now this is the string, and to the string is attached a ball whose mass is 2.5. Now this ball which is attached to the string, now the string is making an angle of 45 degree with the vertical. So string making an angle of 45 degree with the vertical. Then the question says they have given you the center of the circle to the point of attachment. This distance, that is the height, is given 2.5 meter. Okay, so let this be the radius which is unknown to us. Now first of all, what we will do, we will solve this right angle triangle to get the radius, because radius is unknown here. So here we can apply tan 45 is equal to perpendicular upon base. Tan 45 is 1. Now here you can see perpendicular will be r. So opposite to 45 we have perpendicular as r, and base will be this portion, that is 2.5. So from here we are getting radius as 2.5 meter. So we have got the radius. Now as this ball is rotating about this horizontal circle attached to the string, so there will be the tension in the string. Now this string is having a tension T. Now breaking it in its component, we get T cos 45 and T sin 45, and in this direction will be the weight of the ball mg. Now here you can see in equilibrium position, this component T for cos 45 will be balancing mg, and this component of tension T sin 75, T sin 45 will be providing the necessary centripetal force. So we will be getting it this way. See, T sin 45, it is providing the necessary centripetal force mv square upon r. This is the first equation. And now in the vertical equilibrium we have T cos 45 balancing mg. So we have T cos 45. So T cos 45 is balancing mg. So we are getting this second equation. Now let's divide these two equations. So on the left side you will get T sin 45 upon T cos 45. On the right side, mv square divided by this will give you v square upon rg. So this will cancel out. Sin 45 upon cos 45 will give you tan 45. So here you are getting tan 45 is equal to v square upon rg. Now let's substitute. So v square will be tan 45 into rg. So tan 45 is 1. Radius we have calculated 2.5, and gravity in the question is given as 10. So we are getting v square is equal to 25. So from here we can get v as 5. So in the first part, now in the second part, they have asked us to calculate the tension in the spring. Now to get the tension in the string, we can use the second equation. T cos 45 is equal to mg T cos 45 1 by root 2. Mass is given 2.5, gravity given as 10. So T will be equal to 25 root 2. So if you simplify this equation, then you will be getting it as 25 into 4. So you'll be getting 35.35 Newton. Okay. Now moving on to the third part. In the third part, they have asked you to calculate the time period. Now to calculate the time period, so time period will be equal to distance moved in one round, that will be 2 pi r upon the velocity. So we have 2 into 3.14, radius is 2.5, and v we have got as 5. So if you solve it, then the time period is coming 3.14 seconds. This is clear to you now?